KCF Technologies presents Industrial Transformation, Stories of Failure and Success from the Frontlines of American Manufacturing.
Welcome back. I am Jeremy Frank, the host of the Industrial Transformation Podcast, and I'm very excited to have another guest to speak with this morning. Our guest is Mike Ruszkowski, who is the Senior Program Manager at the Electric Power Research Institute, known in the industry of power generation as EPRI. And for those who have been following along, this is the fourth installment of a four-part series where we've been taking a deep dive into some of the important happenings in the modern and future electric power generation sector. We've talked with Lauren Poindexter of Ameren Callaway, who is in innovation for both nuclear and fossil power plants. Then we've talked with Jason Babick of Westinghouse about the innovative things happening there. And then we've talked with our own Adam Dalo, who has worked in the power gen industry, in nuclear specifically, and has now been driving change from inside a technology company. Now I'm very pleased to be able to speak with Mike Ruszkowski, who is at the center of the organization that globally drives innovation and change for the power gen sector. So, Mike, welcome to the podcast.
Thank you, Jeremy. I'm really excited to talk with you around what KCF has been involved with and where we see the power industry going on a global scale.
Wonderful. Yeah, I'm really, really glad to have gotten to know you only fairly recently, but I've known EPRI for quite some time, and I think I understand the mission and purpose of EPRI, but can you tell us just a little bit, introduce us to EPRI, and then also just your specific role within EPRI?
Yeah, absolutely. So like you said, the Electric Power Research Institute, but EPRI in general is it's a global nonprofit research and development organization that's really looking at all aspects of the power industry. So the power producing assets from a fossil side, renewable side, and nuclear side, all the way down to the meter to the end user from a residential and commercial side and everything in between. And we were born out of a blackout in New York City back in the 1960s, and the industry came together and said we need somebody to be looking long term because our focus is really immediate needs for our customers and our equipment. So in the 70s, EPRI was born, and we've always had this approach of looking beyond the horizon and looking at where the industry is going, that maybe the stakeholders and the companies involved don't have that far line of sight because they have to worry about the day-to-day immediate needs.
So, Mike, I'm really interested. If you know the story, I'd be curious to hear a little bit about what that incident was in the 60s that tripped off the need for EPRI.
Sure. So, what happened was it was maintenance issues and lack of asset management that led to a blackout up in the Northeast, in particular, affecting New York City, which ironically, both my parents are from New York City and were in that area during the blackout. And, because companies were really focusing in on the end product and the bottom dollar, it was identified across, it was self-identified by the industry that there was a need for, a company or an institute to be looking long-term research for the better of the overall, power industry that was kind of detached from, in particular, utility or even from the government. And that's where the nonprofit, Electric Power Research Institute kind of was born out of that blackout.
Okay, that's wild. I mean, there's so many ironies to unpack there. Just that it's, so what is that? 60 years ago, in the very place where Thomas Edison pioneered electric power generation with Nikola Tesla. We were talking about that in the Westinghouse interview. But then here we are. So you have the incident that is maintenance driven and triggers the need for EPRI. Here we are 60 years later dealing with the same stuff, although obviously we've made a lot of progress there's still a lot of challenges out there. And then on top of that, we're in the times of this COVID crisis that are putting particular stress on that exact type of thing, maintenance and the ability to keep machinery operating. I'm curious, take us to the present. What are you seeing in terms of EPRI's interaction with these utilities trying to operate through this COVID crisis?
So it's actually a great question, and I kind of want to take a step back to almost a little bit pre-COVID, because we've seen such a dramatic shift in how power is being used around the world. We always talk about at EPRI, and I'm sure anybody that's in the power industry has heard the term the duck curve, looking at when demand is needed more, normally in the morning and then towards the afternoon as people are arriving at work and leaving work. And with the onset of continued development of renewables and gas prices being as low as they are, we've seen a shift of less overall demand, but a higher peak and lower valleys, which then means the ramp rate is substantially higher. So less power is needed, but when it's needed quicker. So we've seen that effect on the power industry on how you manage your assets. Now, fast forward to, like you said, Jeremy, to the COVID times. Now you're still trying to maintain that. The power demand has dropped off because some people will think and say, well, everybody's working from home, so people are using their air conditioning, using their lights substantially more, and that's true. But that's almost a drop in the pan when you look at the larger commercial and industrial areas that are not being used versus residential. So we've seen a drop in overall demand, but our members and the utilities are still having to operate their plants safely and reliably with almost a skeleton crew in some instances. So there's a big focus on what tools can be used, and things like data analytics, sensor technology, remote subject matter expert with using mobile devices to kind of fill that void of things that used to be more face to face or person to person. And it's been a struggle, but I gotta say, 20 15 16 years in the power industry, I'm always amazed by how resilient people can be when their backs are against the wall, and how to still progress, but at the same time maintain that core aspect of safe, reliable and efficient power production.
Yeah. I'm so glad to be speaking with you because I just find it fascinating. I was speaking with a different slice of the power gen industry that's kind of focused on reducing those key demand points from a capacity standpoint, capacity trading. But just in the process of that, we were quantifying just some of the assets that we monitor, and I think something that would blow people away is that there are pumps and fans large enough that they consume $1 million worth of electricity a year, or sometimes more. And when you talk about turning your lights off or not running your shower, those things are important cumulatively. But there's one single pump in a big factory can consume as much as thousands of people. It's amazing when you see it up close. I'm curious. So I know that you're specifically deeply focused within what I think EPRI calls generation, but gas-fired plants and coal plants. My understanding is that the gas plants and peaker plants specifically are the ones dealing with that greatest, these volatility shifts that you speak of. What is it that you see there? What are the biggest challenges within coal or gas that companies are currently dealing with?
So you're right, definitely right when you talk about it. The gas is probably the heavy lift and the biggest burden on this, because they were, those plants, both simple cycle, which is just, the gas turbine to an exhaust, or a combined cycle where the exhaust from the gas turbine heats up, water into steam that goes to a steam turbine. So you're pretty much, getting, double the power output for the same, fuel source. They were built for a better flexibility. And our coal units, similar to the larger coal units to nuclear units, were built for large base load. So they're both they're both feeling this effect. For the coal plants, it's interesting. I don't think it's any surprise or to anybody that yes, coal plants are retiring, not only in the U.S. but worldwide. Many companies have come out with reduction of their carbon footprint by 2030, 2040, 2050, and an easy way to do that obviously is the retirement of coal plants. However, there are still valuable coal assets out there that are being used in a flexible operation mode. And, they've had to make changes to controls, to their automation, to how the operators work with the equipment. Whereas, a gas plant is a little more automated because they're a little newer. I guess it's interesting when you say new in the power industry, that's usually 20 years or less. So, for us in a world that, old is, your cell phone is 2 years old, that's old, new in the power industry is definitely a different take on it. But, you know, from the coal side, I think the biggest, struggles we see is just, the efficiency, having that right fuel source and really you're limited in some instances. It's a catch 22. You're limited on how low you can go in power and how quickly you can ramp up based on your environmental controls on a coal plant. But those environmental controls, such as a fuel gas desulfurization for your SO2 or selective catalytic reactor for your NOx, are needed just to keep that plant online. So you're limited by that. From a gas plant, I think the limitations really come to, you know, you're it's really about the people, the amount of people. And what I mean is at a coal plant and a nuclear plant, I'll use a nuclear plant as an example. For a 2,000 megawatt dual unit plant, you would probably have about 1,000 to 1,200 people on site, which means you have a fully vetted maintenance staff, fully vetted engineering staff. At a coal plant, you may be in 100 to 150 people for, a 500 megawatt, 600 megawatt plant. For a two-unit combined cycle plant that's maybe around 800 to 1,000 megawatts, you're talking of a total staff of maybe 30, more likely around 20. So you're limited on what you can maintain and what you can operate. And granted, these plants were made for some flexibility. They're not made to be started or stopped, 7, 8, 9 times a week. So you're straining the engineering design aspects of some of your equipment, and and this is where the data analytics comes into play, is how do you get ahead of that curve? So not everything you're doing is reactive, because if anybody's lived in a reactive world, you never get ahead. It's always going to be a downhill snowball effect.
Yeah. Well, I know it well, and it's just so interesting because I'm actually looking out my window. We're adjacent to campus at Penn State University, and we've had a collaborative relationship with the Penn State steam plant for well over a decade. But it's a combined cycle and now a cogeneration plant also, where they take the waste steam heat and pipe it throughout campus to heat the buildings. In fact, it's a funny thing. On campus, if you ever walk on Penn State in the wintertime, the sidewalks never have snow on them because they very intelligently laid that out so the steam heats the sidewalks. But from a power standpoint, it's really quite a state-of-the-art thing. And they went through that change. So when I was in grad school, it was a coal plant, and they used to truck the coal in from Kentucky, and you'd see, 30 trucks come down College Avenue every day. And there was dust all over the wall or the windows of the engineering building from our co-founder, Gary Koopman. We used to talk about that. Anyway, they went through that, and it's now a gas-fired cogen plant. And we see that same thing here with the reduced staff. A couple questions. So when you're we know we're especially deep on the balance of plant equipment, the ID fans, FD fans, boiler feed water pumps, even the valves, things like that. And that's the stuff that I think, if you're operating on a skeleton crew, from my observations, that's the stuff that really bites you, because it's just not possible to have you can't stand there and babysit all the pumps and fans and smaller equipment throughout a large plant. Mm-hmm. So what do you do? And I also know that, the power gen industry across, coal, nuclear and gas has been really a laggard in terms of adopting this technology, at least in our experience. So most of them are flying blind. What do you see? Like, what do you do? What are the risks if you have a fan or a pump fail catastrophically and you're dealing with it reactively? Like, what are the consequences that people are then faced with?
I mean, it's a great question. I think you hit the nail on the head when you talk balance of plant equipment. Um, you know, just prepping for this, I listened to the previous webcast, and it was really interesting listening to Jason from Westinghouse talk about with the larger units. When you look at the steam turbines and the generators, and even the some of the larger transformers, they've always had that sensor capability because for lack of a better term, they're really expensive and people don't want to replace it, so it's easier to put money up front to know what's going on and what's the health of that piece of equipment. But previously, even going back maybe a decade ago, it wasn't cost feasible to have additional sensors and information coming from your balance of plant equipment. Maybe your boiler feed pump, because that's a critical thing, but more times than not, it wasn't the major critical equipment that led to issues. It's like you said, the valving, the pumps, the fans. And people, I don't think people in the industry think of it this way, but sometimes people forget that it's all interconnected. If you had, I'll use a perfect example with a coal plant. We have these fans that strictly just move air from the outside into the coal mill to get the right measurement of air to fuel ratio, so you get the right burn rate and right flame intensity in your boiler. Now, if that fan goes down, it may be a minor fan, but now you're not getting the right rate, which means you may not be able to use that coal mill, which means you might have to take that coal mill off. Now, more than likely, the plant has, repetitiveness built in, but if one of the other ones is down, now you're derated. So the impact can be seen from a power output, which then correlates to financial. And it's not just the financial aspect of loss of megawatts output. Now you have to take into account, um, you know, reactive maintenance is always more expensive than preventive maintenance. So now you're circling to either bring people in on overtime in house or reach out to contractors. Now, if you might need to build scaffolding, you might have to take other equipment off, which is then going to reduce your power output even more. It's a trickle down effect in the sense as one piece of balance of plan, if you don't maintain it, and like you said, we haven't had the capability to babysit it, can lead to potentially a complete shutdown of the plant, a forced outage, and hopefully it doesn't occur, but it could occur, catastrophic failure to bigger equipment. So luckily, we live in a world now, like everything that is technology, price drops dramatically as it becomes more and more built out, and you build out the different revisions, and we're at a place now where that sensor technology and that information can be put on your balance of plant equipment and give you that line of sight on those things like the valves, like the fans, like the pumps and motors, that now you're getting a better sense of what your plant actually is looking like versus this is what my steam turbine looks like, and everything that's feeding into it and feeding out of it is kind of a black box.
Yeah, so it's just there's a fascinating dynamic here, Mike, because and you just you're exposed to it. I'm so curious to understand your view on this next part. And by the way, everything you just said, we see that all the time, and the one part of it that you didn't highlight that I think is an additional interrelated factor is safety. Just because, like, not only are you scrambling to fix the equipment reactively, and that has a cost, it's more expensive to do it that way. But this has been studied by the Department of Defense, other parts of the government, by the aerospace industry. The most risky industrial activity is a maintenance person performing reactive work, because you're running around with your house on fire trying to firefight. That's when people slip. That's when they hit their head. That's when they hurt their hand. Sometimes they die. It's all of those things. What I want to talk about next is, so we're obviously you've gotten to know us and some of the core experts in our company, it does work. The sensor, the cost of putting wireless health monitoring sensors on all this equipment has come down. But what I think a lot of people don't realize, and I've like lived this deeply, it's been that way for a long time. So, we got our start into this, what's now called IoT, IIoT, Industry 4.0, all the way back in 2004. And it's actually interrelated with EPRI tangentially. We were funded, there was a program from the Department of Energy. It was the Industrial Technology Program Office that's now the EERE, the Energy Efficiency Renewable Energy Office. And they funded several companies in what was called industrial wireless for the 21st century. And there were some experts at Oak Ridge National Lab. We probably know some of the same people. Anyway, that was 2004. And it was, GE and Emerson and Honeywell or Eaton were part of it, as was KCF Technologies. And the truth is that the sensor technology wasn't what it is today, but it was functionally affordable. And yet many companies attempted to do it and failed at a pretty large scale. Some really, most large companies, including the ones I just mentioned, took a pretty good, attempt at doing this and were not able to be successful. And I'm curious, I have my own point of view on it, but I'm curious, especially from 2010 on, 2015 for sure, the technology has not been the holdup. It's not about being able to put a little wireless sensor on a machine and solve the problem. From your point of view, what do you think is the holdup? Like, why has this not been achieved at large scale in these power plants?
To your point, Jeremy, there has been a slow process, and I really truly think that it's that cultural acceptance in the power industry. The power industry, when you look at it from all aspects, has always kind of built and prided itself on its people. They could do anything. They're keeping the lights on 24/7, 365. And now, we've seen it for years on the fossil side, and even the last decade on the nuclear side with the nuclear promise of reducing O&M costs by 5% across the entire fleet. We've been living that on the generation side. So there's still pushback, but now it's not a convenience that says, oh, well, there's technology out there, but why do I need this technology when I've got an operating shift or I got mechanics that could go out and put their hands on it and they know the plant. They could walk in and hear if a vibration is on the feed pump because they've been around it for years and they could tell that difference. But now it's a necessity. So now we're seeing that. I think the other thing that's happening is we're seeing this transitioning workforce. If you look at the numbers, the average age of the workforce is decreasing, for two reasons. One, we're seeing the retirements. The power industry kind of had gaps in the 90s and early 2000s where they didn't hire. So you're seeing this, this age decrease. So now you've got this new generation of personnel that are working in the plants or supporting the plants. And they've grown up with technology. So they want that. That's what the needs are. That's how they can, that's how they understand it, how they learn, and how they can do their job. So again, now that's playing into the necessity of it. So I think that's why we're starting to see that creep forward. The third thing is we have to take into account renewables. In particular, I want to talk, wind turbines and photovoltaic on a grand scale. Those plants have no personnel. So everything is done off of technology with sensors and data analytics and pretty much their equivalent of a control room looks like a large scale monitoring and diagnostic center. So now you have this aspect that's building up continuously in the power industry worldwide at a rapid pace, and it should be, but they have no fallback on sending Joe the mechanic or Jim the operator out to the plant. They have to live in that technology world of sensors and technology and data and preventive and advanced pattern recognition, those areas that they're pushing it, and now everybody else is doing it out of necessity because everybody's being asked to reduce operations and maintenance costs.
Yeah, that's a fact, and it's interrelated, right? Because of the low price of gas and because of essentially free operating cost of renewables, at least maybe nearly free, everything is being stressed from a cost standpoint in a good way. I mean, there's such a good story in that for both for the environment and sustainability and for the consumer. All of us will gradually be getting lower and lower prices, but it really puts a lot of pressure on the backbone. I mean, the very same plants that make it possible for us to live now are being squeezed by those same dynamics that are really good in the long term. There's just there are ironies across the board. It's really wild.
It's amazing, and it's fun. It's fun. It's funny that you say, like, it is leading towards lower prices, but it's also putting strains. I talked about flexible operation for some of these larger base loaded units, and when you look at it, it's always fascinating because when the sun's highest in the air, up in the sky, and you're really accumulating the most from your solar panels, it's when the power demand's at the lowest. So now you don't have really that storage, and that's where potentially moving forward, bulk energy storage comes into play. You have all this sun generated power in the middle of the day that's not needed. So now you're asking your coal units and your gas units to ramp down as low as possible and almost potentially operate at a negative impact. And this is where there's we could talk power, the power markets, but that's a whole nother time. But it's just so fascinating because, like you said, you pull one string and everything unravels. Nothing's isolated.
Yeah, yeah. It's funny I want to come onto another topic that's related, but that what you just described, I have talked with some people that are living that very intensely in Arizona. The big utility in Arizona, and specifically the Palo Verde nuclear plant. It's what is it, Arizona Power and Light, APL?
Arizona Public Service, APS.
APS. I know one of the leaders at Palo Verde, and they're in this dynamic where they have had the equivalent of a public referendum saying that they want to be fully sustainable and especially photovoltaic by a certain date, an aggressive date, and yet that's one of the biggest base load generators in the whole world, and those two things just don't match up unless you have the ability to store a tremendous amount of electricity, which currently isn't possible. So it creates these impossible situations that they're dealing with. I wanted to come back to something that you said because I think it's really important. And we, by the way, I guess I would say lethargy or reluctance for the power gen industry to adopt these at this point proven technology. There's not many companies that can do it, but those that can, it's proven. I mean, this works. The different sectors, we have exposure to that, and there's ironies there too, where for example, like 10 years ago, we actually looked at this strategically and had poked at a number of industries, and we concluded at the time that there were three sectors that were the best ones to focus on: power generation, like utilities with a primary focus on universities, like commercial buildings, basically, and district energy facilities, and then paper and pulp. And of those three, we basically gave up on power gen and university utilities for a while, like years. And paper has been a steady uptake. I mean, there are paper plants where we have thousands and thousands of sensors in single plants, and companies have installed across their whole base. Yet power gen and oil and gas, so many people have described to me the same dynamic in oil and gas that you have in power gen, which is that they're just used to the same old way of doing things. They're reluctant to change. And yet our experience has been that when we hit a tipping point, particularly in the upstream sector, they have been the fastest and the best at adopting the new technology. Mm-hmm. And so I think a lot of it does come down to the people. The wild thing about power gen, when you talked about manpower, is that is that there is sort of like this magical bridge because you have the younger workforce and they're more embracing of technology. However, you know as well as I do that many times that piece of equipment was installed in 1920, and the guy who's been working in the plant since 1972, he knows a lot about how to make that machine, that pump or fan, run in a healthy way. And what's amazing is because of the connectivity of the data, like having it in the cloud, you can actually bridge that gap from the experienced person to the new person, leveraging technology if you could just convince them to use it. You can actually listen to the health of the machine remotely, and then he can talk to the young engineer and say, look, this is the funny sound out of all the sounds it's making. This is the sound that means that the bearing is failing or that it's imbalanced or whatever. And that's the way it works. I mean, we see that particularly in the COVID time, because those guys are probably the most stressed part of the workforce during COVID as well.
Yeah, and I know, guys, we've talked over the last couple of weeks and talking about you and your team and how you've worked. I always find it fascinating to talk about other industries, like talking about the paper and pulp and how we have this being in the power industry since I've got out of college. We always have this aura of, hey, we're we're the tip of the spear. We're keeping the lights on, but you know, you look at other industries that are, similar heavy industry, heavy equipment industries that have been able to make these changes. And, it's a great analogy you talk about of being able to take the information off of the equipment and understand and kind of make that connection between, the mechanic that's been working on it for 20 plus years with the new engineer strictly through looking at the data and building off of the experience that was in the past. The one nice thing about the data, I think, is it takes away the maybe, I don't want to say bad habits, but what one of the things that we always sometimes have a concern about is, and it comes back to the key point you talked about with safety, is you work around the equipment so much that you understand it, you know what it's telling you, you know how to maintain it. You also know the ways of maybe workarounds to do it a little more efficiently. And now you're shuffling forward with a new mechanic or a new engineer, and they'll they could understand the information, but they don't know those workarounds, and that's where you get into a potential of safety. And that's why the information is key, because it's going to make everybody do it the same way, and learn from those other things. Build in the fact that, hey, when you see this uptick in this acoustic signature, this is usually saying that your inboard bearings going off, and here's a list of what could potentially leading to that. It could be debris, it could be wear, it could be improper lubrication. And then you start pulling that thread. Well, when's the last time a lube oil analysis was done? When's the last time that bearing was changed? Check the work order. Did it have the proper steps? Was everything done? Was anything noted when they replaced it? And that's where we're getting to. The next step is for the technology to do all that work and come back to the engineer and say, hey, your bearing's going because the oil that you put in was not the correct oil. Here, the work order's been put in play to change that out for tomorrow on day shift. And oh, by the way, we've shut that pump off and went to the backup. And now the engineer just has to monitor and keep track of it. That's where we need to get.
I like that. Yeah, and it's interesting just with all the buzz of the Industry 4.0. There's a lot of people talking about that, but one of the dynamics I see is that they're skipping the hard work of actually getting that, whether it's tribal knowledge or bad habits or intelligence and intuition. It's both, but in each particular case, it's one or the other. The hard work of actually getting that knowledge out of the people who know the machinery, in my experience, that's been one of the main failings of those that have attempted, whether you call it IoT or Industry 4.0. If you don't do the hard work of actually solving real problems in real plants, then you can't get to that future state. And that's something we've just been experiencing deeply.
Yeah, I mean, and it's a good point. It's the hardest thing for two reasons. One, sometimes some of that information is difficult to extract, and sometimes that individual is holding on to that information because that's their golden nugget. That information is what's going to keep them viable at the plant because people see technology as not as a tool to help, but as as for a lack of a better term metaphor, the Skynet of Terminator 2. It's going to replace me. And
Right.
that's not where we need to be. And the
Yeah.
other thing is really, what it comes down to is um, people aren't staying in positions for 20 years anymore. The average time I think that the next generation stays is 2, 3, 4 years. So you're bouncing around. So it's like every 2 to 3 years, it's almost a reset. So we need to improve the capabilities of getting that information to those individuals quicker, so that they could get into that they could be successful in that position quicker, knowing that their shelf life is less.
Yeah. I could continue this conversation for I think hours, Mike. I find this just fascinating. Just to start wrapping it up because we are running out of time. What Lauren Poindexter has done at Ameren Callaway, which interestingly enough, they went in the reverse order of what you described, which I guess in retrospect was more difficult than it had to be because it started in nuclear and then he's spread it fully to all their fossil generation. But it's been exactly that dynamic. They invested a couple $100,000. They've already documented over $1 million of savings. But the more important dynamic from his point of view has been those team dynamics. There are always some skeptics at the beginning, but once they see something that works, people just want to make electricity and they want to not get hurt. And when it works, people turn into believers pretty quickly. It's just a great dynamic. I just want to start wrapping up, and there's a couple more questions I have for you as part of the wrap up, but it maybe cues into that. I'm just curious. So for all the things we've talked about and all the things you do in your work, what would you say is the single biggest problem that you wish you could eradicate if you had like a magic wand or something?
Um, I think it's the you know I think the biggest thing, and I think one of the biggest hurdles that I wish I could easily just wipe away is that cultural, you know, mentality or thought process that we see across the world in power plants that, you know, technology's here to replace me. I think that that hinders so much because you and I know that anybody could do a top-down approach and say, "Thou shall, embrace this technology and do it." But if you don't get buy-in from the people and the workers that are using it on a day-to-day basis, it'll never succeed. And I think that's comes back to the point that we talked about why there's been a hindrance in the power, generation industry versus maybe some other industries.
Hmm.
And we're getting there and we're seeing it with some tools, some things as simple as like some of the digital worker head mounted tablet that a 20-year operator vet used it and said this is great. You're starting to get that buy-in. And if companies are keeping those people involved, whether it's a shift or what we'll call a steering committee at a plant, and that buy-in starts on day one, it makes it so much easier. But it's that it's that hill that is always difficult to overcome, no matter what scenario you're in, no matter where in the world you're at.
Yeah, change is hard, or at least if you think people think it's hard. It's not always hard, but yeah. What about the future? So if maybe just that one problem, but many problems. If you take us out, like I like to think of 2030 as the future. I know in power gen it's more like 2040 or 50 that people like to talk about. But whatever the future is for you, how good do you think it can be? Like if we really do this, if we do the things we're talking about well, what do you think the future can be like?
I mean, I have such a positive outlook on the future for just the power industry in general. I mean, it's not going away. I'm sitting here in my office with two monitors and lights and air conditioner running. We're always going to need it. It's just there's the opportunity to continually make it more efficient. And what I love about the power industry, and it's one of the things that drew me to it, initially on the nuclear side, is the diversity. Like you really truly need every aspect of it. Coal will have a role in some aspect. Gas will always have a role. Renewables will continue to grow. Bulk energy storage, will find a place. Um, Looking at low carbon, low carbon fuels like hydrogen are starting to be developed more and more. It's always fluid, for better or for worse, I guess. I've seen the negative side of that fluidness of the industry, but there's always an end game of you know making sure the people and your end users get that power. And with all the tragedy and with everything going on in the world right now that we're living through, the amount of resolve and work I've seen in the power industry to kind of keep those lights on, knowing that their power production is critical to commercial units like the hospitals and like people's homes that maybe need that medical treatment, and how can they adapt quickly. And that's what really I guess gives me that hope and that positive outlook is, if and when it's needed, we can adapt quickly. And I think coming out of this, there's going to be some silver lining as to, hey, we were able to do these things with technology, with people in place, and there was a marriage of it. And how do we keep that? How do we take that from a an incident of a pandemic, but build it into our daily business plan and move forward with it? And that's my positive outlook.
I love that, Mike. That convergence of technology with people making positive changes. That's KCF's whole vision for the world. So I love that you bring it to that. And it's also, by the way, that's why we chose the power gen sector. The criticality and the resolve in the necessity of this sector is why we chose this first, kind of during this crisis time. Because I just agree with everything you've said. I have one last question for you that's really about you kind of personally. Well, personally, but in your work and your outlook. I'm curious if you can tell me something that you really believe, something you really know to be true, but that others don't agree with you about yet.
Yeah, I mean, I can't say that everybody disagrees with me on this, but I maybe have a little more uh, resolve around it. Is no matter what happens, I still see, coal power being viable power generation in the industry, and not just for, developing countries, but even established, countries like the United States. Um, I struggle sometimes because when we talk climate control and climate regulation, a lot of times what the images you see are of these smokestacks with this just dark clouds billowing out of it. And it's from the 70s and 60s, and like you go to a coal plant now, and there is a such thing as clean coal.
Hmm.
It sounds ridiculous, but there is. We have done such an amazing job in the power industry as a whole to reduce that those emissions. Now they're still there, don't get me wrong, but I think there's still technology out there of maybe recirculating that flue gas through a system where you can scrub it even more. I think there's opportunities because the fuel source is cheaper, and we don't know what happens with gas prices. Things are volatile always, and one hiccup can lead to higher prices, which then it's a ripple effect. Like we talked about, everything's interconnected. But I do see a, a, a niche area in the power industry that coal will still be viable. Not in every region of the world, but I still see it being there, and I see technology that's going to continue to improve those emissions and the automation and the control logic and all those things, where you could potentially see a coal plant get down to where you have a staffing of 10, 12, 15 people, or ultimately be completely remote operated from a central location and have multiple units. So that's, I'm biased. I've worked in the coal, I've worked in nuclear. I see value in both of them. And I know sometimes they're both under fire, but I do see, the coal, industry from a power production side still being viable for those reasons.
Well, that is just fascinating, Mike. I'm just so I'm always just intrigued by divergent thinking, and I think it would be an understatement to say that kind of the long-term viability of coal that's very divergent in the current climate. If you watch TV and watch what's being discussed, but I think it's the experts who take the effort. Put in the effort to understand the real facts who know. And that's something I'll actually personally have to educate myself a bit more about. So I really appreciate you sharing that. And I just appreciate this discussion. I really feel like I could talk to you for several hours about these topics, and maybe we'll certainly be talking to each other. But maybe a future interview again for some more follow-up. But we do have to wrap up. I want to say thank you very much for being on the Industrial Transformation Podcast. Do you have anything that you'd like to say or share in closing?
I mean, just really, I just wanted to thank you, Jeremy, for reaching out and having me on the podcast. It really has felt like a conversation, and that's great. And I could talk hours on it, and just really appreciate the time I got with introducing and meeting your team and seeing how KCF Technologies is working, not only in the power industry but other industries, and kind of helping bridge that gap. It's really impressive, and I look forward to continued conversations.
Yeah, likewise. Well, thank you so much for your time and the work that you do, Mike, yourself and with the Electric Power Research Institute broadly. I very much enjoyed this conversation, and we'll look forward to catching up next time. This is the Industrial Transformation Podcast, and I'm Jeremy Frank.
Thanks for listening to the Industrial Transformation Podcast, a production of Business Builders Media. Learn more about how KCF can help you on your industrial transformation journey at kcftech.com, and check out more shows on businessbuildersmedia.com.